Welcome to the channel Maths for Graduates. Today we will solve this question. In this question we have to find infimum and supremum of this set S. Okay. Before we start solving, let us know what is infimum and supremum of any set. Okay. So let's see what is an upper bound. Any real number m is said to be an upper bound of set S if m is greater than equals to x for all members of S. Okay. Let us take an example. Suppose we have some set interval 0 1. Okay. And we can see that 1 is an upper bound because all members of set S is less than 1. 2 is also an upper bound because all members of set S is also less than 2. Similarly, 3, 4, 4.5 all numbers are upper bound of this set S. Okay. Now the question arises, what is supremum? Okay. So supremum is also known as lowest upper bound. In short, we write it as LUB. Okay. So from the term lowest upper bound, most of the things are clear. That means from all the upper bounds, if we form a set of all the upper bounds, then smallest member of the set of upper bound is known as lowest upper bound. Okay. Let me frame this into a definition. If set of all upper bounds of a set S has the smallest member, say that member is capital K. Okay. Then K is called least upper bound or supremum of set. Okay. Now let's see what is lower bound. For any real number m, this small m is said to be lower bound of set S if m is less than x for all x belongs to set S. That means this small m is less than all the members of set S. Okay. Then this small m is said to be a lower bound of set S. Okay. Again, taking an example, taking set S as interval 0 1. Okay. And we can see 0 is lower bound because all the members of set S is greater than 0. Minus 1 is also a lower bound, minus 2 is also a lower bound, minus 3 is also a lower bound, and all the members in the left hand side direction of the real number line, all members are lower bounds. Okay. Now let's see what is infimum. From this set of lower bounds, we can find a greatest member, then that number is known as infimum or greatest lower bound. Okay. Infimum is also known as greatest lower bound. Okay. In short, we can write it as GLB. Okay. So for this set S, infimum is 0. Okay. Why so? Because among all these lower bounds, greatest member is 0. Okay. And here supremum for this is what? Supremum for this set S is 1. Why so? Because among all these upper bounds, 1 is the lowest upper bound. Okay. I hope these definitions are clear to you. Let's find the supremum and infimum of this set S. Okay. So in set S, elements are of type 1 plus minus 1 raised to power n over n. Here n is some natural number. Okay, so we can write this as 1 minus 1 over n when n is odd, and 1 plus 1 over n when n is even. Okay, why? Because we know that minus 1 raised to power n is minus 1 when n is odd, and it is 1 when n is even. Okay, okay. So writing some members of this set as, so when n is 1, first element will be 0. When n is 2, second element will be 3 by 2. When n is 3, third element will be 2 over 3. When n is 4, fourth element will be 5 by 4. When n is 5, fifth element will be 4 over 5, and when n is 6, sixth member will be 7 over 6, and so on. Okay. So these are the elements of set S. Okay. So on seeing these elements, from our intuition we can say that 0 is infimum and 3 by 2 is supremum. Okay, because from all these members we can see 0 is the lowest and 3 by 2 is the greatest. Okay, so it is our intuition that 0 is infimum and 3 by 2 is supremum. So let's prove our intuition. So I am going to make a claim that claim 1, that 0 is infimum of S, and claim 2 is 3 over 2 is supremum of S. Okay, now we have to prove these two claims, right? Okay, so we will prove these two claims in two steps. Okay, first, to prove for claim 1, in first step we will prove that 0 is lower bound. Okay, and in the second step 0 is the greatest lower bound. Okay, in the same manner we will also prove claim 2 in two steps. In first step we will prove 3 by 2 is an upper bound, and in the second step we will prove 3 by 2 is lowest upper bound. Okay, so let us start proving claim 1. So our step 1 is 0 is lower bound. Okay, okay. So elements of set S are 1 plus 1 over n or 1 minus 1 over n. Okay, okay. So here n is natural number, right? That means n is greater than equals to 1. From here we can say that 1 over n will always be positive, right? Okay. Now from this we can also say that 1 plus 1 over n will also be positive. Why? Because 1 is positive and 1 over n is positive. Addition of two positive terms will always be a positive. Okay, okay. Now for this 1 minus n, here we have n is greater than 1. From here we can say that 1 over n is less than equals to 1, right? Multiplying minus 1 on the both sides, and we know that when we multiply any inequality with negative sign, then direction of the inequality changes. Okay, so this will be on multiplying minus 1, it will be minus 1 over n greater than equals to minus 1. Okay, now adding 1 on both sides, so on adding 1 this will be 1 minus 1 over n is greater than equals to 0. Okay, so these two members of the set are always greater than equals to 0. Okay, so from here we can say that we have seen that all the members of set S are greater than equals to 0. So 0 is the lower bound. Right? Okay. Now let's prove step 2 that 0 is the greatest lower bound. So for this, let us first assume that there exists a lower bound which is greater than 0. Okay, so let's assume that, let's assume there exists a lower bound greater than 0. Okay, so we can write such lower bound greater than 0 as 0 plus epsilon, and epsilon is positive. Okay, 0 plus epsilon, this quantity will always be greater than 0, right? Okay, so what we are saying, we are saying that this 0 plus epsilon is lower bound. If this quantity 0 plus epsilon is lower bound, that means all the members of set S must be greater than this value, right? Why so? Because this is the lower bound, but element 0 is less than this 0 plus epsilon. Okay, why so? Because epsilon is some positive value, and we know that positive value is always greater than 0. Okay, so here we can see that a member of set S is not greater than this lower bound. That means this cannot be a lower bound. That means our assumption is wrong. Okay, hence we can say that this 0 is the greatest lower bound. Okay, so infimum of set S is 0. Okay, in the same manner we can also prove for supremum of this set S. Okay, so let's start. Proof of claim 2. Step 1, that 3 by 2 is an upper bound. Okay, all right. So this term minus 1 raised to power n over n, this will be 1 over n when n is even, and this is minus 1 over n when n is odd. Okay, since n is even and n is natural number, so n will always be greater than or equals to 2. So from here we can say 1 over n is less than 1 over 2. Okay, that means all these members when n is even always be less than equals to 1 by 2. Okay, and these members when n is odd will also be less than 1 over 2. Why so? Because this is negative value. Negative value will always be less than a positive value. Okay, so in general we can say that minus 1 raised to power n over n will always be less than equals to 1 over 2. Okay. Now adding 1 on both sides. So on adding 1 plus minus 1 raised to power n over n is equals to 1 plus 1 over 2. So from here we have 1 plus minus 1 raised to power n over n is less than equals to 3 by 2. Okay. So this 3 by 2 is an upper bound. Okay. Now let us prove in step 2 that this 3 by 2 is lowest upper bound, right? Okay. So let us proceed towards step 2. Three by 2 is lowest upper bound. Okay. So again we will prove this term. Again we will prove this statement using contradiction method. First I will assume that there exists a upper bound which is less than this value 3 by 2. Okay. So let us assume there exists a upper bound less than 3 by 2. Okay. Suppose that upper bound is 3 by 2 minus epsilon. Okay. Obviously this quantity will be less than 3 by 2 because we are subtracting some positive quantity with this value 3 by 2. Okay. I have assumed that 3 by 2 minus epsilon is an upper bound which is less than this 3 by 2. Okay. Now we can clearly write this as 3 by 2 is greater than 3 by 2 minus epsilon, right? Any confusion? Because when you subtract any positive quantity with some value, then that value will always be less than the original value. Okay. Now this member 3 by 2 is a member of set S. So from the definition of upper bound, all the members of set S must be less than the upper bound, but here there exists a member of set which is not less than the upper bound. That means this 3 by 2 is not an upper bound. So our assumption is wrong. That means 3 by 2 is lowest upper bound. Okay. So supremum of set S is 3 by 2. Okay. So this is the solution for the given problem. If you find any difficulty, you can ask me in the comment box below. And I have a quick announcement to make. Those students who are preparing for exams like CSR Net, GATE and other MSc entrance examination can buy our real analysis handwritten notes for a very reasonable price for only ₹80. If you are interested, you can contact us through this WhatsApp number. Thank you. Thanks for watching.